Hey everybody, it's Jim Kemp with 705 CNC. Hey, in this video I'd like to provide an update to my previous video. That one was CNC vacuum holding done cheap and easy. In that video I showed, a complete vacuum system, how to set it up, how to make your own plate as a vacuum fixture, went through all the bits of the system. And kind of the magic of the show was having a vacuum pump controller. So in this video I'd like to provide an update on how we're getting along making a DIY vacuum pump controller that you could either build yourself or buy a kit potentially from us that would have all the parts, or buy a complete system all ready to go. So in this video I'll go through the vacuum pump controller and show exactly where we're at with that, and give you all the details. Hey, thanks a lot for all the great feedback and comments on the last video. The comments really help a lot. You can't imagine how much that gets people motivated to crank up and work on this stuff. So thanks again for all those comments. Really got Timmy and I, and my son Josh, he's also going to work on this thing too. So there's three of us actually working on this thing. Simply because you guys put in a lot of comments and feedback and cranked up the view count and subscribers. So that really helps a lot. Thanks a lot. So this design is going to be all open source. I'll make everything freely available, and can download any part of it and have at it. So it looks like there's basically going to be three different ways you can do this. You can completely roll your own, download from GitHub, and make it any way you want, obviously. Second path is we'll put together a little kit of parts. So a lot of the parts you have to buy like in 3s or 5s, and it's just irritating. If you want to buy one of these little toggle switches, this thing, you have to buy 5 of these from Amazon. If you want to buy the little encoder knob, I think these are also in groups of 5. The little LCD display, you have to buy 3 of those, and it's just irritating. You only want one of them. So we'll put a kit of parts together so that you can 3D print your own enclosure, and you can just put these parts together from the little kit that we'll throw together. And then finally we'll sell a full-blown kit, fully assembled and ready to go. So that's the 3 different ways I see, 3 different paths to have your own vacuum pump controller. Thought we'd start off and look at the old gauge, get some inspiration from this thing. It had some problems. I mean, right off the bat, nobody called me out, but the scale is inches HG, but the actual display says millimeters HG, so that's obviously wrong. So I got to correct that right off the bat. The next is it's got a tiny little font down in here to show the actual pressure. Unless you got your super spy glasses on, it's unreadable. So that needs fixed. And then there's a couple other little graphics on here that I tried that didn't really work out. So yeah, and then it had this crazy housing. That's really not the best. You see the ESP32 is just kind of hot glued down in there. It's got wires hanging out of it. Yeah, this thing, but it's been working for a couple of years now. So, but it could definitely use some improvements. One of the biggest problems with this thing is the fonts were hard coded into the ESP32. So they were stored in the flash file system on the ESP32. So if those weren't loaded ahead of time, the ESP32 would crash. So yeah, from a software perspective, this thing needs some upgrades as well. Lastly, this thing is running on a graphics library called TFT eSpy. It's a low-level library that drives the display, and even the new design is going to be based on that as well. But then all the software that I wrote just sits on top of that low-level library. So it's not the best. It's hard to use. So there's another library that sits on top of that library called LVGL, and it makes programming a lot easier. And we'll get into that in a minute. So here's the new design. It's still got some stuff hanging out the back, but don't worry, we'll get that all cleaned up. We're gonna do a custom little circuit board. You can see in this guy, I've got a little rack mount that can have a circuit board slide in here. I'm gonna have a custom circuit board made that will clean all this wiring up and make it a lot easier. So, but this is basically it. It's it's a 3D printed housing, on-off switch. You can still move the carrots around the outside. Right now I've just got a little pot to simulate the, see if I can hold this all together. So you can simulate the pressure swinging around. So now the font is much larger. The little LED inside the display actually works to show you when the pump is on. So the little LED turns off. I'm not sure that shows up that great. But as the pressure comes in back down below the lower set point, LED comes on to let you know the pump should be on. And then when it goes above the upper set point, it turns off. Basically, that's just it. But a lot of cool stuff, like if you notice the needle is going underneath the numbers, underneath the live numbers, but over the top of the gauge numbers, over the top of the LED. So a lot of little things like that. And then this got a little spinny thing here at the bottom, let you know it's actually running. It's not just stuck, otherwise, the software could get jammed up and you don't know, but a little spinny thing lets you know that it's working and doing its thing. This is all based on the ESP32 module. These are really inexpensive from Amazon. That's where I get them. This is just a plain ESP32 module. This is called a Wemos D1 Mini 32. And make sure you get the version that has the 2 rows of pins on the edge. There's a slightly cheaper version that has just a single row of pins on the edge. So you definitely want to get the 2 rows so you get more functionality brought out to the edge. So and then the other half of it is this little round LCD, 1.28 inches, I believe. Don't worry, all this stuff is going to be in the BOM. It'll be called out in a spreadsheet, where you can get it, the part number, price, all that jazz. So, but yeah, this one's a JXL, not sure. The problem is you have to buy 3 of these to get the super low price. It does come with a pigtail cable, which is nice. And it comes with these monster M3 mounting points. So one other feature of the software is I'm going to make it so that you can build it so that you don't need the display or the encoder. So basically it would just be a raw analog on-off switch, right? So if the pressure gets above a certain level, it turns the pump on. Gets below a certain level, it'll turn it off. And you can just recompile the software to change where the set points are located. So you don't need all the GUI and the knobs and all that stuff. You could just basically throw this in a tiny little enclosure and off you go. Bob's your uncle. So the idea is that these things are going to plug onto the circuit board. I'm going to make a purpose-built circuit board. I use KiCad for my design software, and that works really well. I'll make that open source and freely available as well. So, the ESP32 will solder down or plug onto the circuit board we're going to get made, and it'll then have connectors that will then interface the LCD, the on-off switch, and the encoder, and then that will just slide in on this rail and sit in there, and the cover will go on with the pigtail coming out. So then there'll be a second box that will have the relays and the power supply and all that other jazz. So this will be low level, idea that it sits up on top of your machine, and then the relay box sits down near the floor, plugged into 110 volts. So yeah, so the 3D enclosures come along pretty well. This all prints with no supports needed. You know, it's got these little, I'm not sure you can see those well. It's got these little ramps in here underneath these guys, so it progressively gets wider, so you don't need any support material. And then I've got a printer in the shop that prints on flat stuff, so this lettering is really tough. This printer just does a fantastic job. So yeah. Even though the sensor is really fantastic, I still added a bit of software filtering to the sensor to make it more stable on the screen. So it's kind of a two-stage filter. First, it does a median filter, and this is configurable in the software. You can rebuild the software for any depth of median filter you want. But basically, a median filter is it takes a new value and it adds it to a ring buffer, and then it takes the ring buffer and it copies it to a working buffer that it then sorts, and it grabs the middle value out of that sorted list. And what that does is, if you have a flyer that, you know, every now and again, if the value just pops and then comes right back down, those flyers will get eliminated in the median filter. The median filter returns the median value of a group of values. So I take the median value. I think it's not very long. It's only like maybe 10 or 15 values. Take the median value out of that and then run that through an averaging filter. And the downside of all that filtering is it adds delay. So you can see, like, okay, I'm at all the way at 0 right now. And if I turn the pot as quick as I can to maximum, there's a bit of a delay right before it pops there. So yeah, filtering just adds delay to your value, but the value is rock solid. You know, once it gets to its value, there's none of this dithering around on a value. It just pretty much sits right there. I mean, it might change every now and again. I hope you can see that at 21.7, 28, it just sits right there. There's none of this screwing around, right? Which is nice, in my humble opinion, right? I mean, but it's all in the source code. You can easily change or eliminate some of this stuff. Just a feature of the software I thought was cool. One additional feature we'll add to this new version is we'll have an alarm output. So if you're in a noisy shop and you have a vacuum leak that is so serious that it can't maintain even the low level, we'll have an alarm output come on, so you could turn on a flashing light or a siren or both, or whatever you want to hook up to that. So we'll make that a viable output. So right now the software has been completely rebuilt and has all the functionality of the one that I'd been using for a couple of years now. But there's some cool stuff that could be added. One of the potential things that would be nice is to be able to calibrate the thing. So, you know, you could apply an exact vacuum value. So where I'm going with this is trying to create like a 3-point calibration. So you apply a known vacuum level, right? So suppose you put exactly 5 inches of mercury on it, and then if you press and held the encoder knob, right, you press that in, hold it, it would say, oh, you're very close to 5. You must want to calibrate to 5. And then, you know, you'd apply exactly 15 inches of mercury and do the same thing, press and hold, and it would then recompute the 3-point calibration to these new set points. So maybe 5, 15, and 20. If you held the knob with the value close to that, it would recompute and then give you a very accurate needle for vacuum. Personally, I found that that's really not that big a deal. You know, you just bloody well want to have the vacuum come on whenever it's below 20 and go off when it's above 25. If those values are, lower or higher by 3 or 4 inches of mercury, well, that might be an extreme, but these values don't have to be very precise. You just want to have basically more than 20 inches of mercury holding your part down. But a 3-point calibration would be kind of cool, and it's just software. The other cool thing would be is if you ever move these set points with the encoder knob, as soon as you stop moving them, after a few seconds, they should be stored in non-volatile memory so that the next time you power up, they would be on these new values and not revert back to what's baked into the software. So a couple of enhancements that we'll get to as these things come out. Oh, and then one other quick thing I thought was just really cool. I printed these TPU feet, and inside here are some cavities that you can put some little circular neodymium magnets. So if you stick this thing on top of anything metal, it just doink, it pops down and holds on, which is just kind of cool. When you set it on top of your machine, you don't want it going anywhere. Just one more little cool thing, I think. Thought I'd show quick is this Squareline Studio, which is the software that helps you build the GUI that LVGL then uses. So if I open the project for this little gauge, I can zoom this guy up a little bit. Whoops, a little too much. But one of the things I thought I'd show was like, how the needle went underneath the live display. So if I grab the needle object and I come over here and change the rotation angle. So yeah, right now you can see how the needle is underneath that guy. So all I have to do is just come up here to these guys and reorder them, set the preference or the priority level, and now the needle will go over the top of it. And then all you have to do is just say export UI files, and it will rebuild all these C files for you and put them in the right directory. Well, if you set up your project right. So if I come to project settings, project settings, you have to tell it where you want the UI files to be exported. So this goes into my Arduino directory, the vacuum gauge, source, and then UI LVGL file. So if you set this up to a directory inside your Arduino project, it will just automatically update those files for you, and then you just recompile the Arduino code. And if I did that right now, the live numbers would be below the needle instead of on top of them. So you don't have to have this Squareline Studio. You can just build the software as is. But if you want to make any changes to anything, change the colors or potentially I could see people coming in here and want to change the scale, right? If you wanted this to be millimeters HG or bar or some other value, you could come in here and edit this stuff and change all this stuff to your liking, and then just re-export it and rebuild the project and download, and you should be off to the races. This is just the BOM for all the hardware. This is just early on. It still needs to include some more stuff that I'm missing, but this is just a kind of a starting point to give you an idea. So the basic bill of materials around $60. But if you have to buy all the parts yourself at these minimum quantities, you're closer to $120. So just depends on which way you go. Okay, this is the KiCad, and we're trying to design that little circuit board that's going to slide into the enclosure. So here's the ESP32 with all the wiring for it, and then over here we've got the on-off switch, the rotary encoder with the push button, and then down here at the bottom the LCD. So these colors that are called out on the wires are specific for that particular brand of LCD. Different vendors like Waveshare makes their own version. There's a couple other guys on Amazon that make these things, and they would probably have a different color coding. I probably should remove this and just go with the numbers only, but it's kind of handy when you're trying to make sure you're not making any mistakes in wiring these things up. So then over here we've got the analog vacuum sensor coming in with a little filtering and the resistor divider network. And then this is showing a circular connector on the back of the enclosure that shows a signal wire going down to the second enclosure. The second enclosure is down here. It's got a 110 volt plug coming in, going through a little power supply that steps it down to 5 volts. And then little small relay module, little dual relay module. I'll show you a picture of that here in a second. And then the alarm output and the vacuum pump on-off control will come out of that little relay. So we'll talk more about this second enclosure in a bit. Okay, this is the original relay box that we had. This thing was Timmy built this, and had these magnets on the back, which are pretty cool. So this thing would stick on the back of the machine. Had we bought the enclosure from Amazon. I believe it was Amazon, but anyway, so it's got a power supply down in here, and then it's got the little small dual relays down in here, right? So the little dual relays are driving the big monster relay. So a couple of upgrades that we're planning on doing to this box is, firstly, we replace that big power supply with one of these little power modules, right? So this thing will take anywhere from 100 to 240 AC and generate 5 volts at 3 watts. So that should be plenty to drive the ESP32 and the display. So cute little scudder. Hopefully it works well. And then, I was thinking maybe of using one of these kind of relays. It's replaceable. This relay would be driving the actual pump, but these are kind of expensive. And then worse, maybe I can really zoom in on this thing. It's 1/6 horsepower. So even though it claims 10 amps, 1/6 horsepower. So evidently the inductive snap from the motor drives this thing crazy. So it will burn up the contacts. So, we found these on Amazon, and this thing claims 80 amps, 250 volts AC. So holy cow, this thing really, and the contacts in here are just ginormous. So this thing really ought to last forever. And that's what we ended up with inside this thing anyway. So, and this thing worked, it's been I think we put this in 6 or 9 months ago, and seems to be working really well. So I think that's what we're going to end up with. So it'll be this giant relay with this little power module, and then that little small dual relay in one enclosure. So that'll be the relay enclosure box. Oh, and then the sensor as well. We'll put the sensor down in there as well. So no sense having to run a vacuum line all the way up to the top of the machine where the display is. We'll keep the sensor down there. We'll use some shielded wire, so even though it's analog, it shouldn't be a problem at all. Okay, I thought I'd just show real quick the Arduino source code stuff. So there's not a whole lot to say about it. Well, there's this extra tab here, notes. So it's just a placeholder to hold just a ton of comments about the stuff. So instead of putting it in the main section, you can pop over there, and I just put a ton of comments in there to explain how the software is all built. So in the main stuff, if you have this declared, this use GUI, it's going to do the full build, and with the LCD and the whole enchilada. But if you want to build a stripped down version, you just comment that out and rebuild the software, recompile it, and it'll dump all the GUI stuff. So the values, the switching points will be hard coded with these two values up here. So that's pretty much it. You just put this stuff in here and hit compile, and as usual for Arduino, it just takes it forever for some reason to compile. Even if you don't really make any changes of any amount, it still takes it forever. So yeah, here's pin assignments. Yeah, you can read through this stuff and see what it's doing, but it's not using much of the resources of the ESP32. There's tons of extra capabilities in this thing. So the main part of the code isn't really that long, even with all this extra filtering stuff I threw in here. In total, about 200 or 300 lines of code in total. So really not that much stuff here. So most of it's done in these extra files. Like all the encoder stuff is over here in encoder. You can see, pop over here and see how the encoder is being handled. But even that's not very big. Most of the code is actually in the GUI stuff, which is buried in a subdirectory. So that's pretty much it. So make any changes and then just recompile and download. That's it. Pretty straightforward. So good news, we've got both Josh and Tim on board. They're both real excited. Tim's working on the relay enclosure, getting a circuit board made for that, getting that design all fleshed out. Josh is working on Shopify so that we can take orders and process all that through, setting up a website. We've also got GitHub set up, so everything is going to be put up on GitHub, all the bill of materials, all the KiCad files, all the source code, everything you need to completely reproduce the project will be up on GitHub. So trying to think if there's anything else. Stay subscribed and stay tuned. Both GitHub will be updating, and we'll come out with a follow-up video as soon as we make some more progress on this thing. We're going as fast as we can to get this thing churned out. So I would expect that we'll at least get a kit of parts put together here in the next week or so, and we'll get that up on Shopify so you can at least buy a subset of the parts. You don't have to buy all the larger quantities that Amazon and these other vendors require to get some parts. So keep an eye out for that. So I think that's about it. Let me know in the comments section. We really love the comments and suggestions. So it's a big motivator. So I think that's about it, though. Thanks a lot, and thanks for watching.